Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Let's discover our next function family. So I'm going to start with this exponential growth problem or function you see right here. And I have a few values to get us started. So I'm going to start with 0 just because that's easy. So let's go 2 to the power of 0 equals 1. So if I put in 0, I'm at 1. If I put in input 1, I get out 2. So 1 is 2. And 2 to the power of 2 is 4. Okay. Now let's do the other side. 2 to the power of negative 1. Now the negative on the exponent just means that the base is a fraction, so this becomes 1/2. Up here now, 2 to the power of negative 2 is 1 over 2 squared, which is 1/4. So we go to negative 2 1/4 just like that. So you can see my scale. Here's 0. I put a 5 up top, so that tells you the y-axis is by 1s. I put a 6 here, so that tells you the x-axis is also by 1s. So we're just going to sketch now this behavior. Now let's sketch its inverse. Remember, the inverse is when we take the inputs and outputs and switch them. So in this point, this ordered pair is negative 2 1/4, so we're going to switch it. So the input is 1/4, that means the output is negative 2. Take the next point and switch it. So this is 1/2, negative 1. Okay, so now we have our ordered pairs, so let's graph it. Let's start with the bottom numbers here and work our way towards the top. Okay, so these functions are inverses of each other. Look at that symmetry. 1 0 0 1, 1 2 2 1. So remember, the ordered pairs have that relationship where they interchange. So let's analyze their characteristics now. So let's look at f of x. Its domain, so this is exponential, is all real numbers. Its range is all positive y values. The y-intercept is 0, 1. The asymptote, it is asymptotic to the x-axis. It is always increasing. And it's end behavior. Okay, now let's look at this inverse. One of the things about the inverse is, if you remember, when you interchange your inputs and outputs, or in other words, the ordered pairs, the x and y coordinates, the domain and range switch. Let's see if that happened. What's the domain on this function? Notice it doesn't go past the y-axis, so its domain is 0 to positive infinity. What's its range? Well, it appears to always kind of be increasing, doesn't it, in both directions. It's going to continue to head down at negative infinity and continue to grow slowly in that positive infinity. So it appears to be all real numbers. And look, they switched. Now, does this have a y-intercept? No, it doesn't, but it has an x-intercept. What is it asymptotic to? Well, it's definitely crossing the x-axis, but do you see how it's avoiding the y-axis? So it's asymptotic to the y-axis. Okay, intervals of increase, decrease. Well, if we read left to right, we can see the function is increasing the entire time. Now let's look at end behavior. As x approaches positive infinity, the graph is also approaching positive infinity. Now this time we're going to modify this a little bit. Normally we would say as x approaches negative infinity, but this graph, this function, doesn't even exist to the left of 0. So we're going to say as x approaches 0. What is this doing? Well, we can see the graph is actually headed down towards negative infinity. Okay, so let's look at some of these characteristics here. So the domain and range switched for these two functions. The original function had a y-intercept, but its inverse had an x-intercept. Notice the lines that they're asymptotic to switched. They're both still increasing. Their end behavior is not quite that similar, not really a decent switch there, or an obvious switch, but these are very, very much similar to each other. But again, these are inverses of each other because, remember, an inverse function is reflected over the identity function, right? You see that? They are reflections over each other. Well, this inverse has a name. The inverse of f is a logarithmic function. So the inverse of exponential functions are called logarithmic functions. So the equation for this inverse would be as follows. That is the equation, or the inverse of our exponential.